Look up at the night sky. What do you see? Is it just a scattering of distant lights or something more? A vast, mysterious expanse that has inspired wonder for as long as humans have gazed upward. The moon, a few planets, and countless stars scattered across a vast, dark canvas. Each point of light is a story, a world, a possibility suspended in the endless black. It's a humbling view, a reminder of our smallness. But now, imagine not just seeing the universe, imagine listening to it. What if, along with the light from distant suns, sound could travel across the cosmic ocean? What if every star and planet sent out not just light but music, whispers and roars that could reach our ears? Would you hear a gentle hum, a chaotic roar, or a symphony beyond imagination? Would the universe sing to us, or would it overwhelm us with its noise? For all of human history, space has been silent, a universe on mute. The vacuum between the stars carries no sound, only silence. Movies fill the void with whooshing starships and booming battles, but reality is far quieter. The true cosmos is a place of profound silence, where even the most violent events unfold in utter quiet. Yet silence doesn't mean inactivity. The universe is alive with violence, creation, and motion. Stars are born and die, galaxies collide, and planets spin in their orbits. Every star is a nuclear furnace burning with unimaginable energy and power. Every planet, a world of its own, with storms, mountains, and mysteries waiting to be discovered. Galaxies colliding in cosmic dances that last millions of years, shaping the universe as we know it. Imagine, for one day, the laws of physics change and sound travels through space. Suddenly, the universe is not just a spectacle for the eyes, but a concert for the ears. Suddenly, Earth is bathed in the universe's auditory signals. The silence is broken, and we are surrounded by the music of the cosmos. Would we be terrified or inspired? Would the sounds of the universe fill us with awe, or would they be too much to bear? How would hearing the groans of dying stars or Jupiter's magnetic hum change our view of the heavens? Would we feel more connected, or more alone? This thought experiment pushes us to experience the cosmos in a new way, through hearing, not just seeing. It challenges us to imagine the universe as a living, breathing entity full of sound and sensation. By imagining a universe we can listen to, we make it more tangible, more relatable. We give it a voice, and in doing so, we bring it closer to our own experience. We try to bridge the immense gap between our small world and the infinite expanse beyond. We reach out, hoping to understand, to connect, to belong. So, open your mind, and let's listen together to the symphony that's been playing on mute for billions of years. The universe is waiting for us to imagine what it might sound like. Why is space so quiet? When we look up at the night sky, it feels like the universe should be filled with sound. After all, so many incredible things are happening out there. But instead, space is silent, almost eerily so. The answer is simple. Sound needs something to travel through. On Earth, we hear because sound waves move by vibrating the molecules in the air, water, or even solid objects. When you speak, clap, or play music, those vibrations travel through the air to reach our ears. Underwater, sound travels even faster, and through solid ground it can move for miles. But in space, there's almost nothing, just a near-perfect vacuum. There are so few particles that they're separated by vast distances. The particles are so spread out that sound waves can't travel. The vibration dies instantly, unable to jump from one particle to the next. That's why astronauts need radios to communicate even when floating side by side. Their voices can't travel through the emptiness between them. Their voices create vibrations, but with no air between them, the sound stops at their lips. The only way to talk is by converting their voices into radio signals. Radio waves, a form of light, travel through the vacuum just fine, but sound cannot. That's why space missions rely on radio communication. This is why the universe, as we perceive it, is wrapped in profound silence. No matter how violent or energetic the events, we hear nothing. In rare places like nebulae, sound waves can exist, but at frequencies far below human hearing. These cosmic sounds are more like deep, slow rumbles that take years to travel even a short distance. Even where space isn't perfectly empty, it remains silent to our ears. The vastness and emptiness make it impossible for sound to reach us. The cosmos is a silent movie, not because nothing happens, but because there's no medium for sound. In space, the drama unfolds in absolute quiet, leaving us to imagine the sounds of the universe. In our imaginary world where space carries sound, the sun would be the loudest neighbor. The sun is a violent, churning nuclear reactor, its surface boiling with massive convection currents. Solar flares would crackle like cosmic lightning, and coronal mass ejections would boom across the solar system. The sun's surface, covered in granules the size of Texas, would hiss and seethe beneath the deeper roar of its core. Other stars would have their own unique sounds, a young blue giant's intense hum, an old red giant's mournful groan. Each star's sound would reveal its age, size, and life stage, like a signature in the sky. The most dramatic event? A supernova's deafening roar, echoing across light years, the sound of creation and destruction. Listening to the sky would be like walking through a forest of unique animal calls, each star telling its own story. The universe's soundtrack would be epic, chaotic, and beautiful. Beyond the sun's roar, each planet would add its own voice to the cosmic orchestra. Earth would rumble with tectonic plates, whistle with jet streams, and crackle with lightning. Jupiter's magnetic field would create a chorus of strange whistles and hisses, while its great red spot would drone like a never-ending storm. Saturn's rings would shimmer with the gentle chime of colliding ice and rock, a cosmic wind chime. Mars would whisper with thin, ghostly winds, and the ice giants would hum with turbulent, high-pitched atmospheres. Comets would fizz and crackle as they approached the sun, like cosmic dry ice in water. Every world, from the largest planet to the smallest asteroid, would add its part to a rich, ever-changing symphony. The solar system would be alive with sound, each body contributing its unique note. The universe's orchestra would be vast and endlessly varied. Beyond our solar system, the universe's most powerful objects would create mind-bending sounds. Black holes themselves are silent, but their accretion disks would scream as matter is torn apart by gravity. Merging black holes would send out gravitational waves, a low-frequency chirp, space-time ringing like a bell. Nebulae, the birthplaces of stars, would rumble with thunderous shock waves and hiss with jets from newborn stars. Galaxies would hum with the collective light of billions of stars, a steady, overwhelming baseline. When galaxies collide, the sound would be a slow, grinding crescendo, igniting a firestorm of star formation. The universe would be filled with the rumbles, hisses, and roars of creation and destruction. Each cosmic event would add a new movement to the grand symphony. The scale of sound would be almost impossible to comprehend. While we can't hear space directly, scientists have found a way to listen: data sonification. This innovative technique allows us to transform the silent language of the cosmos into something we can actually experience with our senses. Instead of just looking at numbers or images, we can now listen to the universe's hidden symphony. Sonification translates cosmic data, like brightness, energy, or even the movement of celestial bodies, into sound. By mapping these measurements to musical notes or tones, scientists create audio representations of phenomena that would otherwise remain invisible. Higher data points become higher notes, lower points become lower notes, revealing patterns our eyes might miss. This process can turn a simple graph into a melody, making complex data more intuitive and engaging. LIGO's detection of gravitational waves became a famous chirp when sonified, making the discovery instantly real. That brief sound captured the collision of black holes, a cosmic event billions of years in the making, and brought it to our ears. NASA has turned Hubble and Chandra images into soundscapes, letting us hear galaxies and nebulae. Each color, brightness, or position in the image can be assigned a unique sound, creating a rich audio tapestry of the universe. Sonification isn't just for fun, it's a powerful tool for analysis, especially for visually impaired astronomers. It opens up new ways to explore and interpret data, making astronomy more inclusive and accessible to everyone. The human ear is great at picking out patterns, sometimes better than the eye. Subtle changes in pitch or rhythm can reveal trends or anomalies that might be overlooked in visual data. Listening to a sonified light curve can reveal hidden planets or subtle changes in a star. This approach has even helped astronomers detect exoplanets and study variable stars in new ways. Sonification opens a new window to the cosmos, making the universe accessible in a whole new way. It transforms abstract data into something tangible, something we can feel and connect with on a personal level. It's both a scientific tool and a bridge to public understanding. By turning data into sound, scientists can share discoveries with everyone, sparking curiosity and wonder. Through sound, we experience the cosmos in ways we never could before. deepening our connection to the universe and expanding the frontiers of discovery. If we could truly hear the universe, it would transform our relationship with it. Space would feel alive and present, not cold and distant. Imagine stepping outside and hearing the sun's hum, Saturn's chimes, and the Milky Way's distant roar. The universe would become an immersive, living environment, not just a silent picture. These sounds would evoke awe, fear, and wonder, making the cosmos feel personal and intuitive. Children could learn about stars by listening to their life cycles, making abstract science tangible. The sounds of Earth would feel precious and unique amid the cosmic noise, reminding us of our planet's rarity. Hearing the universe would be a constant reminder of our place in the grand story. Hearing space would revolutionize music and art. Musicians would sample the raw sounds of the cosmos, the sun's roar, black hole chirps, comet hisses. New genres would emerge, galactic ambient, stellar metal, and more, inspired by real cosmic sounds. Composers could create symphonies using the actual sounds of the universe, blurring the line between nature and art. The rhythms of pulsars and the melodies of merging black holes would inspire new musical forms. Art installations could let people walk through sound maps of galaxies, experiencing the cosmos firsthand. Our creative expressions would become a dialogue with the universe itself. The music of the spheres would become a literal, audible reality. We've journeyed through an imaginary universe of sound, hearing the sun's roar, planets' whispers, and black holes' screams. This new sense would deepen our connection to the cosmos, making it feel alive and immediate. The universe would no longer be something we just look at, but something we listen to. Sonification bridges the gap, letting us hear the silent data of the cosmos. When we listen to a black hole's chirp, we're hearing the universe's story in a new language. Scientific exploration is about extending our senses, finding new ways to connect with reality. The universe is playing a symphony of unimaginable complexity, and we are both its audience and a part of its orchestra. So next time you look up at the stars, imagine what you might hear.